Hi, my name is Alan Sweeney, and I'm here today to talk about the Camfil Gold Series Campaign Dust Collector. It's a safe change bag in, bag out dust collector for the pharmaceutical and HP API industry, but dust collection in general is an important part of industry. For those of you who don't know much about dust collection, you bring a dust. Hi, my name is Alan Sweeney, and I'm here today to talk about the Camfil Gold Series Campaign Dust Collector. It's a safe change bag in, bag out dust collector for the pharmaceutical and HP API industry, but dust collection in general is an important part of industry. For those of you who don't know much about dust collection, you bring a dust-laden airflow into our dust collector, which is going to remove the dust from the airstream and allow it to go on to atmosphere or to another filter system in a clean way. What we do here, this will be mounted on a hopper, and the first thing that the dust will hit is a set of baffles inside the inlet box, which knock out the heavy dust straight to the hopper. They don't see the filter, makes the filters last longer. The dust that does get through loads up on the filters inside here, which are hanging vertically, very important for cleaning, and the reverse pulse periodically by a 4 to 6 bar compressed air tank, where about a quarter of the filters are pulsed intermittently, so that you still got your full airflow available, but cleaning is online during operation. No need to shut down. The air then goes on and leaves through your clean air outlet, typically through the back onto onto another filter system, or perhaps the atmosphere if it's not a hazardous dust. If it's a hazardous dust, you can have a Hepa filter system, either mounted directly over the cartridges, again with easy access, or typically in the case of a safe change operation, a bag in, bag out housing mounted on the floor of your plant room, which is easy to change. You've got a dust collection and separation system. You've got dust-laden air. You've got oxygen. You've all the constituents, unfortunately, of a possible explosion. And pharmaceutical dusts are explosive. So in order to mitigate that issue, we have a number of safety systems. On this collector, because it's a very, very strong and robust collector, we put what we call an explosion vent on one side. This is a certified safety device, which in the event of an increase in pressure, which is what an explosion is inside a dust collector, this will relieve or release that pressure and hence stop the unit from exploding. Again, if it's a pharmaceutical product, make sure we're emitting it into a safe area. If it's not safe to emit to the environment, we can use either an internal flame quench, we can use a suppression system, or we can use valves. Lots of options available. Please talk to us. Fans, fans, cleaning systems, safety systems. They're all controlled by our Gold controller, which typically sits here. Easy access, easy to read. Haven't gotten here today. Sorry, we couldn't get everything to the event, but typically it's mounted here for easy access. And that controls all of the components of the dust collector and sends any necessary alarms back to your BMS system. Irrespective of how long we can make filters last, and believe me, Camfil filters last a long time in the right applications, at some stage they have to be changed. So again, ease of operation, ease of use, and ease of maintenance. In order to change these filters, now in a bag in, bag out collector, you're going to be working through bags. They're the barrier from your people to the product inside on those filters. It's critically important that you either use the instructions that are mounted here or inside the door, which I'll show you in a second. Go to the Camfil website, look at the video, get the operation and maintenance manual, carry out and read the instructions before they change the filters. They don't do it too often. It doesn't take too long to read up, make sure it's done correctly, to stop and protect people, no mistakes. So no matter what happens, in a pharmaceutical site, this will typically be locked. So you have a lock here to ensure you're tag in, tag out if you're going to do any maintenance. They will undo the lock, remove the clamps, very simply release the door. And again, an important safety factor. You don't have to carry the door. You don't have to lift the door. This davit arm ensures you can move the door away to the side on the platform without having to involve any manual handling, training, or possible injuries. And again, inside, instructions available if they can't get to see the video. But please see the video, read the manual, be sure they know what to do when I'm going to carry out a safe change training. These doors are here. because we're under negative pressure inside the collector. So with negative pressure, typically the bags are trying to be sucked inside. So we use that door and this equalizing filter to ensure the bag stays sitting comfortably between the door and the door block, but doesn't hinder the cartridges. Because if it hits the cartridges, you're going to lose approximately 50% of the surface area on each of the front cartridges. That's a possible performance issue. We've engineered that out. So when you're performing a safe change, again, the video is online. 2 people, to ensure safety, will open the bag. You've got plenty of glove handles for manipulation here and at the bottom. So again, through the bag, they will open the door and you have access to the cartridge. Again, training. But in a Camfil Camtain dust collector, manipulation and removal of the cartridges is very easy. So for clarity, without the bag, I'll show you exactly how it works. No tools. If you have tools involved in a safe change, there's a possible issue that you may cut the bag or damage the bag and break containment. So what we have are some very easy to manipulate bars, which are released. They drop the filter from the plenum. And again, in a safe change system through the bags, in a standard dust collector, with PPE to protect you from the dust in some way, you very simply remove the filter onto your platform. And if it's non-safe change, use the box that is full of your new cartridges, put it in and send it away for disposal. The filter is the heart of the system, very important part of the system. This is a Camfil hemi-pleat gold cone filter. What we've done is we've widened the pleats outside the industry norm to ensure that we have we can collect dust, but importantly, the pleats are wide enough that it's easy to clean and the dust will blow out rather than stay in the filter. They also, as I said earlier, hang vertically. It's very important that they hang vertically, so gravity, when you're pulsing, dust will fall from the cartridges into the hopper. If they're fitted horizontally, dust falls from one cartridge to the next, and you get binding on top. Because you remove some of the surface area by widening the pleats, we wanted to make sure we didn't hinder performance. So for that reason, in Camfil's filters, we have the gold cone, which is another small amount of media in the bottom of the filter that dust collects on, and that does 2 things. Maintains or increases the surface area that we can put into the filter, but number 2, with a cone, it means that when we get a reverse pulse, there's less volume inside, so that air is used better to remove dust from the cartridges and knock it into the hopper. As I said already, the air then goes on through the outlet to another, in the case of pharmaceutical industry, to another housing, possibly a cam safe, cam box, or another one of our safety housings. And we'll talk about that later on. Thank you very much. Hi, my name is Alan Sweeney again, and after we spoke about Camtain, typically in pharmaceuticals, you would use a safe change Hepa housing either after a dust collector, outside your clean room to protect from emissions to atmosphere, or often inside the clean room in perhaps a wall-mounted type system to keep the contaminants in the room. Either way, this is the Camfil CamSafe. It's a modular system that it's made in cells where we can add another module for more airflow, a pre-filter module if needed before or after, pre-filter or secondary filter. It can come on duct connectors, it can come on legs, or it can be mounted in line in the duct. So plenty of options, good modularity. It can also be installed in a tower format, which can be mounted in your clean room wall with its own completely closing door to keep the aesthetics in the room really nice. But it means you've got your safe change filter inside the room where the particles or potential contamination is being generated. And we've got a cowl on the bottom where you remove the air from the room on your exhaust system up through the filter systems, but it's all inside the clean room. So during changing of the filters or validation, you're not contaminating potentially another room. So look at some of the features of this housing. Now, this is a safe change housing. So one of the simplest features we have is a window on the front. And I'm looking here and there's no safe change bag there. So this is not fit to be used in a safe change format. If there's no bag, it's not suitable for use as safe change, and it's a simple accessory to make sure whether you can see or not. Nothing worse than arriving at a housing, opening the door and seeing the filter. you're directly facing the contaminants. So a simple design feature to keep people protected. And containment is for the following reason. You want to protect people from the product. You want to protect the product from your people. You want to protect the environment from that product and protect from cross-contamination. So containment is very important for all pharmaceutical applications. It's not just a safe change door. To become a safe change housing, it's just not just stick a set of bagging rings and a collar and a safe change door on the outside of the housing. It's got to be fit for purpose. Has it been containment and closure tested to make sure it's acceptable according to ISO 1064882? Has the mechanical strength of the housing been tested according to EN 1886, both for leakage and its mechanical strength? This housing is tested at plus or minus 6,000 pascals and full technical documentation available online. Yeah, it's a safe change housing. Same as you say it's a safe change dust collector. Has it been tested? Perhaps according to EN 689, which is the particle containment test, or according to maybe some of the ISPE guidelines, like the SMEPAC guidelines. Has it been surrogate tested? Have they taken a glucose or a lactose or something and simulated the filter change to ensure that your operators are safe whilst the filter is in its most exposed state during the change? So please ask for those tests. Another simple protective device. We've got a bolt-on door, and these bolts, as you'll see in a little insert into the video, are inserted on the outside of the housing, so not inside. If in the future somebody doesn't tighten it correctly and makes a mess of the threads, you can easily change that bolt without being exposed to inside the housing. A simple feature to make sure people are kept safe and you get longevity out of the product. At some stage, you've got to change the filter. So here, you've got 4 access ports. Very simple to undo them. So we undo the star knobs. You remove the door, and again, it's not a heavy piece of equipment. Protect people from manual handling, etc. You remove the door, set it aside, and then you would typically carry out your safe change in accordance with the trained procedures that we have online in about a virtual reality format, in videos, and again with O&M manuals. But no matter what you do, to filter or use a safe change housing, we need an air filter. And in most of these housings, you're dealing with deep pleated Hepa filters that can do up to about 3.5 to 4,000 meters cubed per hour per cell. Now, at the moment, the best filter for that on the market is obviously a Camfil filter, and I thoroughly recommend the Absolute VG. The reason being, you're typically mounting these housings at this type of height. This filter in the plastic format is 9.5 kilos. The industry average is 18.5. Our metal version of this is just over 11. So again, it's light enough for one person to manipulate. In a safe change bag, I still recommend 2 to make it safer. But it's very easy to move this filter, pick it up, and put it in the housing. When you release the device, you'll be ready and accept the filter for the housing. So again, before you start doing anything in safe change, make sure it's ready. Do it slowly, carefully, so you don't make mistakes. So you literally take the filter, slide it in. So I slide the filter in and it's ready to go. This is where another couple of safety tips and a bit of advice comes in. And again, this housing has its own fail-safe features. In this instance, that filter looks like it's in, but I can still get my hand in amongst the gasket here. So it's not fully in. So in this case, I cannot close the handle. I've got to be sure that I've pushed the filter back completely into the housing before the mechanism here will release and allow me to raise the filter. So it's a very simple change in the handle design, put out in the frame. You cannot but install that filter correctly. Critically safe for a safe change system. When the filter is installed, the gasket, it's most important to make sure the gasket is installed and not damaged. So before you install any filter, when you open the box from Camfil, you'll receive a couple of documents. Storage and handling instructions, always make sure they're gone through correctly. And in the case of this filter, a certificate saying it's ProSafe. And for pharmaceutical processes, our ProSafe range are tested against common decontaminants, common aerosols, cleaning, and other compounds, that might be involved on your sites. So make sure the filter is suitable for use in your application. Again, once the filter is installed, bag is on, we close the door. That's the reverse of what we've already done. Airflow will then go, in this case, from top to bottom. If it's reversed, again, which in wall-mounted housings in particular will normally be the case. If the filter housing is filtering from bottom to top, in that instance, you've got to make sure that your filter is installed with the gasket facing down, but not sliding in on the housing, or there's potential for gasket damage. So in the Camfil case, our filters for bottom to top airflows have a special frame design that we lift the frame still, and the gasket is compressed down. Very, very important to ensure that you get a good seal on the Hepa, which has already been tested in the factory to EN 1822. But when it comes to site, we know it's going to be scan tested again. Whilst ISO 14641 is not particularly relevant for testing exhaust housings, in fact, they're excluded, it still is recommended that you test according to other standards. At the moment, the general way of doing it is this will be obviously attached to a ductwork. So somewhere up in the duct, there'll be a static probe. You shall introduce aerosol and hope you pick up a leak with that one static probe. What we've done with CamSafe is here, introduce the aerosol. We've got a baffle plate and a good diffusion to make sure you get a good homogeneous mix of aerosol. And then take your photometer, attach it here, attach it here. You got your 100% concentration. By moving the scan bar inside the Hepa housing, we pull it forward. And again, we've recommendations for the speed, and you're scanning the full width of the Hepa using a standard aerosol photometer or particle counter. Good advance for the industry to ensure, as you say in Ireland, to be sure, 100% you're testing it correctly. So again, small advances, phenomenal effect for the industry. That's a brief overview of CamSafe, an absolute VG, and we can talk to you more about it online or at the event. Thank you very much.
Since day one, Camfil has been all about clean air. For almost 6 decades now, we have been bringing innovative new products to market, educating our clients and inspiring an entire industry. But the industry is also facing challenges. Air, and particularly clean air, is in many cases just simply forgotten. Remember, air pollution is the silent killer. There's nobody who is really responsible and ultimately accountable for clean air. At the same time, clean air is more important than ever. People are going back to the offices and are more health conscious than before. Organizations need to provide clean, healthy, and productive workspaces. That is why we want to think in new ways and drive change. We need somebody who puts air front and center. Somebody who gives air a voice. Somebody who's ultimately accountable for the air that we breathe. To me, it's very clear and simple. The world needs a chief ergonomics officer. Organizations need chief ergonomics officer, and you need a chief ergonomics officer. At Camfil, we walk the talk. Now it's time for change. And that's why we have appointed our very first chief ergonomics officer. We have started this journey, but we can't do it alone. We're mobilizing all our partners, and we want you to join us. Please help us to give clean air a voice.
Hi, my name is Alan Sweeney from Camfil, and the product demonstration today is the Absolute V filter. The Absolute V filter is a high-capacity HEPA filter, typically up to 4,000 meters cubed per hour, but importantly, at approximately 240 pascals. That's one of the lowest pressure drops in the industry, which means that you will save approximately, at current energy costs, we all know they're changing, about €140 per year in the system, which is up to €700 over 5 years. Very important saving at the moment. What you'll notice about the Absolute V also is that it's got a continuous gasket. So again, it's a continuous poured gasket poured on site in the factory, which means that you won't get leaks from the gasket if it's installed correctly in your premises. It's a unique design in that we've cut down the amount of metal or plastic by using this new shape profile. That does two things: makes it lighter, but still keeps it very, very strong and robust. It also makes it easier to lift because you've got a good place to grip when you're fitting. And fitting the filter is important. The average weight of a high-capacity HEPA filter, the industry average weight, is 18.5 kilos. Absolute V metal is approximately 12 kilos, plastic 9. So that will help in manual handling. We all know over 15 kilos should be a two-person lift. So typically, you're going to have 2 people to install your HEPAs. With this guy, it's light, easy to maneuver, easy to put into a HEPA filter in the wall, in the ceiling, or anywhere else. When you get an Absolute V, when you open the box, you're going to be issued a set of safe handling and fitting instructions. It's very important you read these. You don't want to have anybody damaging themselves or the filter, so read the handling instructions carefully. It's also important to note that this filter is part of our ProSafe range. ProSafe is a range of filters from comfort products right through to HEPAs that have been tested and certified for use in applications where maybe it needs to be food grade. Maybe you're going to use a decontamination agent like a hydrogen peroxide or something. So it's tested against those major contaminants to make sure that the filter will last and function correctly for the life of its installation. It's also important to note that every filter that leaves a factory is certified to EN 8022. So because of that, you will have a unique serial number on the HEPA, which will then give you a test certificate. And that test certificate is used for your validation protocols, for your quality protocols. And very important to note that with a new system we have called Camfil Connect, via a QR code in the front of the HEPA, you can now get that certificate online. So again, ease of use, ease of qualification, and ease of retrieval of information. So that's a little bit about Absolute V. If you want to learn any more, please visit us outside in the exhibition hall or talk to one of the guys in the demo area. Thank you very much. Hi everybody, I'm Alan Sweeney from Camfil. I'm here today to demonstrate the Clean Seal thermal filter housing. Clean Seal is a housing developed by Camfil, typically for use in the high-end clean process industry. In that industry, you might be decontaminating or sterilizing rooms, so the paint quality on Clean Seal is suitable to undergo decontamination, sterilization, or heavy cleaning on site. The housing is fully welded. This means that when the filter is installed, your filter has been scan tested in the factory. You're going to perform a scan test on site. With a fully welded housing, you're ensured there will be no leaks. To install the housing, it's typically installed in the ceiling. And what we have are a solution that clamps onto the housing on the side, and you can either compress down onto the ceiling or suspend from the ceiling. And again, very flexible, very, very easy to install, and very difficult to damage when you're installing it. To install the filter, and it's important to note that there are 4 different depths that can go into the Clean Seal housing. We can put a 66, a 78, a 90, or a 110 millimeter filter into the one housing. that gives you the option to upgrade. If your contractor has applied a 66 mil filter, you want to get lower pressure drop, longer life, you can upgrade to a 90 or 110 mil filter, save energy, longer filter life, etc., etc. To install the filter, it's important to note there are no tools needed. Tools typically mean there's a possibility to damage your filter. No tools, no damage. You have a very simple patented catch. You install the filter, move the catch in front, lock it down, filter is sealed. This clamp can also be fitted in a range of positions. Because of that, we can get to 4 different depths. It's important to note that every clean seal that leaves the factory has its own quality checks carried out. It's checked for size, if measurements are correct, that the filters fitting and clamp settings are correct, that the surface treatment is correct. It's been cleaned, it's packed correctly, and all of the accessories like grill removal card are included. We also use industry standard pressure ports. It's very important that what you're going to use on site is something that's readily available on site. So here we've got a fully welded from outside the housing, flexible inside the housing. You can take the pressure out of the filter, you can introduce your aerosol for testing, etc. When you install the filter and the clamps are open, it's important to note that we've got a couple of holding mechanisms. So the filter goes in and it's held in place and cannot drop. That means one person can in theory install a filter. You've got to obey manual handling legislation, but in theory, one guy can pop it in, let go, and then fit the clamps. So overall, fully welded, high-end coating, very flexible, suitable for, in this case, mounting in the ceiling. We also have a range for mounting in the wall for exhaust. And in the exhaust housing, because it's difficult to test, we've now got a mobile integrity probe. So you have the clean seal, exhaust, mobile integrity probe. You can carry out your validation from the room. That's just a few of the attributes of Clean Seal. If you want to learn any more, please go online, visit us at camfil.com, visit us at the exhibition, or we can meet you later on. Thank you very much.
Did you know that clean air can help you perform 60% better, reduce the number of sick days, and even make you happier? We breathe 15 kilos of air every day, and we spend 90% of our time indoors. Most of that time is spent at work.
We focus a lot on outdoor air, but why don't we focus on indoor air? It can be easier to change and have a huge impact on your health and productivity.
These questions not only keep me up at night, but others too. Up to 70% of office workers worry about air quality at work. But it's time for a change. But where do you start? And who do you talk to?
Imagine for a second that you could talk to somebody in charge, the chief ergonomics officer, a person in your own workplace that could make clean air happen now, someone who cares.
It does not have to be wishful thinking. You can be the person to start this change. Let us all get the indoor air quality we deserve. Be the voice of clean air.
Hello, my name is Michael Feldman, and I wanted to give you some information about the Hepa and Hepa range of products called the Megaland. You see the product here, and what is unique about the product, that you can have it in various dimensions, various frame heights. So this is the frame, the extruded aluminium, and you can use different size of gaskets. When you see the profile here, you would see the gasket itself, and just to show you very unique gasket this is a gel gasket, and you could imagine when the installation in the ceiling is done, then you have a knife getting into the gel and it's all sealed. So as you heard, this product is being mainly used in the ceilings, clean rooms, or any sensitive processes to get really clean air. The efficiency is between H13 and U16 when it comes to the EN 1822, so the background of the testing for these filters. What do you see more? you see here the pack, or let's say you see the grid, and the pack is behind, and the filter pack gives you the right pressure drop, which is according to your application. And using different filter heights and different pleat packs would give you also, or could give you also, a reduction in pressure drop, energy saving. So a product which you can use in all the operations when it comes to really sensitive processes. Every filter is being tested automatically, and it's the leak test is being certified, and also the filter class and the efficiency. So for you, then the quality is really 100% secured. So you see the test result here. There could be one thing probably missing the test results. What do? In this case, there's something unique. On the label is a barcode. And with this barcode, in the installation, you could find the test results just using your mobile phone, have the app, scan the barcode, and you would easily and immediately have the scan test protocol. So the Megalam portfolio and the Megalam product range is the solution for the high-end filtration. And if you want to have more infos, just join us and have the questions in the hall. Thank you.
Bueno, como estamos en sesión streaming, estamos obligados a continuar, no podemos esperar. Nos han quedado.
So we still have two stations that we will visit before we have enjoy our lunches. We'll let you know when, where, and how.
La siguiente presentación la realizará.
Next presentation will be delivered by Benjamin Room, Product Manager, Clean Process Segment in EMEA, and he'll talk to us about housing and air extraction with the characteristics that it incorporates a system to do the integrity test in the filter. And we will share with you the Camfil launch, which is my Camfil Connect. That allows us to obtain the Hepa filter certificate immediately, and therefore have access to its traceability. So, Benjamin, you have the floor.
Thank you, Jaime. So this time I was a bit more clever. I got the translation here, so I know what you said. Last time I was wondering if it's nice or not. You see, always nice. All right, okay. So hello, everybody. Ready for the second half of this day. Thanks for having me speaking here about terminal supply and exhaust housings for HEPA filters. So for you guys down here in the audience, most of you have seen the actual housing out there. So if I present the features now, please act a little bit surprised because the people online haven't seen them yet. A few words about myself. I don't need to say so much. So as Jaime already introduced me, I am the product manager for the clean process products in Camfil for the Europe, Middle East, and Africa region. Yeah, some engineering and also business educational background. I'm living in the north of Germany with my wife and 2 kids, and that should be enough. So about the presentation, we do have terminal housings for supply air into the room and also for the exhaust. Starting with this, I would like to come back to the question we asked our customers before actually starting to develop them. What is really relevant for such a housing? What do we need? What are the most important points? And the answers were, first of all, no leaks, please. Yeah, they have to be airtight, and that's for all the time. Secondly, the validation of the filters should be possibly to do in a very easy and quick manner. It's happening once or twice per year, and you all know that downtime is precious and should be as short as possible. Also, the installation of the actual housing itself should be very convenient. Yeah, there is a risk you're up on 3 or 4 meters height. We should do everything to make this process easier. Also, the filter installation is a very, very critical part of the process. The filter is sensitive, should be handled with care. And once you're up on the ladder, you have different concerns than just not falling down. You really have to be careful with this product as well, because once it's installed, you don't know was it a success unless you test it. And finally, this is more a rather new concern. We also have responses from customers who want the opportunity to change the filter later on in order to save energy. Because there are different filter heights and different versions which may help you reducing the airflow resistance and therefore the energy consumption. How did we answer these questions? Well, no leaks by design. That is the basic concept. It means it is a very robust, fully welded construction, and we don't use any sealant, mastics, and so on. That means it's airtight forever. Easy and quick access to the filter. As I said before, Here we have a very simple and easy front plate locking, no screws needed. Whoever has done that before knows what a struggle it can be to be on a ladder with the air diffuser, using the screw, trying to find the hole, and then you forgot your screwdriver and got to go back down. So just hanging it in the hinge, and then it closes with a click. In order to open that, we need nothing more than just a plastic card, which can be used for that. Finally, this is 100% safe during the cleaning, so there is no chance to accidentally open this. Point number 3, the filter installation. We have added the retainer clips here, which makes this process a lot easier and safer. Zooming in, you don't need a third hand to hold the filter and do the actual clamping. I will just zoom in a little bit more. Here you can see in this animation how the retainer is just holding the filter in place so it doesn't fall down. Once this is done, you have your hands free to do the actual clamping. So you don't need this guy with 4 or 6 arms anymore. They are quite expensive, I heard. So, and then finally for the actual clamping process, also here we don't need any screwdrivers, any tools. You've seen our quick tool-free clamping systems. It's a patented Camfil system, which is very convenient, and it provides immediate filter tightness. So it's always at the right position. That means you can be quite sure that once you clamped it, the gasket is perfectly compressed. Not too much, not too little, because there's also a risk to over-compress a gasket and kill it. Or you under-compress it and you have a leak. And you never know that before you test it. So you save a lot of time here. Number 4, the actual housing installation. Also here, we made a lot of effort to make this as convenient as possible. It's very easy to insert the housing from the room side because all the elements are within the perimeter. That means nothing is larger than the actual hole in the ceiling. So you can come from below and then finally lock the housing with these removable mounting blocks, using them either to suspend it against the false ceiling or suspend it from the concrete ceiling or compress it against the false ceiling. Number 5, what did I say? Scalability of the filter. Yeah, very often we have the case that in one terminal housing, it only fits one filter height. But we want to have the opportunity to increase this height, because here in this animation, we show that in our case, in Camfil, Megalam calls them MD, MX, and MG, different filter heights, which have a different airflow resistance. While we start with 120 to 140 Pascal with the MD, you have a chance to upgrade to an MX filter and have only 90 to 100 Pascal. And finally, the MG version can come with as little as 65 Pascal, or 70 also. And that means quite a bit, because in the long run, this is significant energy savings. So how can we put in different filter heights in one and the same housing? By changing the position of our clampings. So we have here predefined positions for the screw, which will keep the rod in place. And therefore, we can use different filter heights in the same housing. So the active listener might wonder, you mentioned 3 different filter heights. Why is this 4 positions? There is a 4th one. We also have filters with a gel sealing. You know this with a knife edge and the gel. This is also possible to mount into this housing. However, it has to be the right choice, a housing with a knife edge. So that can happen at any time. Once you, I shouldn't touch this. Once you have decided for a small filter height in the beginning, you can still upgrade later. Now, many of you may know this already. So the question is, why am I presenting this? First of all, to remind you on these great features. And secondly, because we have an upgrade there. It's the version 3 now. And version 3 comes with more features, more safety, and more flexibility. What did we change? Most importantly, not a lot. So all the things I mentioned before remain the same. So the most important USPs, the DNA of this product, is unchanged. We keep a fully welded construction. We have the retainer and the clamping, of course, because they make sense. And also the housing support is remaining there. But we have now a full suite of fully welded ports. All these ports have been flex tubes and fittings before, and we found that this can be a risk, and we want to eliminate all of them. That means it's fully welded now. You cannot have any unwanted bend anymore. You cannot have a leak unintended. It's fully welded. And that's true for the 100% port, for the DP port, and also for secondary DP ports, which can be used to connect a manometer or sensors. And also we changed the fitting here in this case, which has been tested to 10,000 Pascal. So it's a very simple, but very effective principle. And that means the whole housing finally is 100% HEPA validation ready. And how do we do that? Is the next part of this presentation. Just after these short informations here, we have, of course, 3 standard gasket types available for these housings and a wide range of air diffuser plates. Clean seal integrity. Just for a little bit of background, I would like to explain what is really important to know when it comes to filter testing. In the past, it has been kind of the standard procedure to inject the aerosol centrally. It's quite easy to follow the ducts all the way up almost to the air handling unit and inject the aerosol centrally, big amounts of aerosol, and it will go down the ducts to the different housings, which are then, of course, challenged by this aerosol, and you can test the filters if they are leak-free or not. But that means, and I have seen that at a customer site last year, it's sometimes quite tricky to get the right amount of aerosol at every housing. So if you start at the first housing closest to the injection point, you may be happy with the concentration. But once you move along the duct to the housings further down, it decreases. And finally, it's too little. And that means the guy in the clean room is calling up the other one as a generator. I need more aerosol. He increases the concentration. And then finally, yes, I have enough now to do the test. But that means the housings up front, at the beginning of the ducts, also get a lot more aerosol than before. And this can be as long as 2 or even 3 hours, this whole process, until we have tested all the housings in the individual rooms. And we made a math in that very case with our customer and found out that the first filter in the system doing this 2.5 hours long process received about 4 or 5 centiliters of oil. So a big schnapps of oil in a HEPA filter. And that twice a year. And that means the pressure drop does increase drastically. The fire risk in the duct increases drastically. And you're not saving energy at all when you choose a good filter and it's increasing with the oil load. Yeah, it's not a good thing. And therefore, we are moving towards local injection. It's much better to really only provide aerosol to the filter that is actually tested, and then go to the next one. And that we do with the clean seal integrity. There are also other opportunities to add the aerosol locally. For instance, there are very simple solutions, like here you just have a flexible tube. From the clean air side, it goes to the upstream side and you connect the aerosol generator. However, using just a simple pipe there or a simple tube will not have any good aerosol distribution. It's going to be at some point above the filter, and it means nothing for the test. The norm actually requires an aerosol distribution which is plus minus 20% over the whole filter surface. So it should be as even as possible. Okay, it's easy to install it when you have just a little pipe there. It's easy for the contractor. They have the monoblock solution to install. Yes, but as I said, it will not give you any good aerosol distribution, and the process is not compliant. Other solutions are also there. You might have round like ring probes, which provide a little bit better distribution. And then in addition, there are also these diffuser plates, which make sure the aerosol is nicely mixed with the air. And then you have a good distribution possibly. It's also good because this is a monoblock solution that can be installed at once. However, it's still not sure that the distribution is really good. And finally, this comes with a systematically high dP, because these parts, these additional parts, they can have 150 to 200 Pascal constantly. The whole year long, you have 200 Pascal more than needed, just for having once or twice for a few minutes the particle test. And that is a lot of energy wasted here. I just described before, you can do an effort to reduce the dP of a filter. Choosing the MG version, you save 70 Pascal, but then you lose 200, and that is, of course, a high waste. Therefore, also, we think this is not a good solution. What do we think is a good solution? Clean seal integrity. So it's basically the same housing as described before, plus we have another injection port added here to the housing. And at this injection port, we can plug the aerosol generator and then connect it to our aerosol distribution part, which is called the Integri pot. The Integri pot consists of a stainless steel injection loop in a standard catalog body ducting element. So tightness class D here in this case. And that's all we need. It should be possible to use this also with any other standard housing. How does it work? So we have a generator starting there, and we connect the aerosol generator with the connection port in the housing. We have a little tool there, so it's easier to connect it next to the filter. And then this port is connected to this Integri pot, which then distributes the aerosol towards the filter, and a 2 meter distance is recommended. If you can have if you can't have 2 meters, 1 meter is also good. We made the test. It still provides a compliant aerosol distribution. But if you have less than 1 meter available, we need to talk. So it might work, but we need to look into this. Another opportunity is to connect several housings actually. So we make a remote injection for 1 to 5 clean seal housings via a so-called Integri box. And what is that? It's another housing at the wall mounted inside or outside the clean room, and we can connect this box to all the Integri pots and then choose the respective ports one by one. So we connect it to the housing number 1, make the test, connect it to housing number 2, etc. Okay, let's look at this from the outside or from a larger scale. So here we have a whole clean room with all these 5 housings, and we have the Integri box in the clean room. That means the particle generator has to be also in the clean room. You need to see if that's possible or not. But if so, you just need one person, because he connects to the respective housing and makes the test, goes to the next one, etc. So only one person is needed to do the whole validation of one room. Also, if an aerosol generator is not wanted inside the clean room, we have that here and there. It can be also mounted from the technical area side, pipe it up with the Integri pots, and then we go ahead. But that, of course, requires a second person who will then make the connection of the generator to the respective port. Who is that? Not me. Sorry for that. So that was the clean seal integrity for the clean air supply into our rooms with the integrity test. I wanted to talk also about exhaust housings. And as I said, we have extended our clean seal family quite a bit, also into the exhaust applications. The clean air needs to leave the room as well. Basically, the clean seal exhaust has the same concept as the clean seal supplier housing, just adapted a little bit for the wall installation. So we have now a different door that can become, that can fit either a pre-filter or not. So there are 2 versions. But other than that, we still have our standard features with the clamping and the opportunity to use the 3 different HEPA filter depths. The door locks, which with a very nice, secure, and tool-free operation. Here you see in this animation, it's just a press and release system, so no tools required still. We have a very easy access to the DP port. Also, this flex tube here can be secured at the door, so we make sure it doesn't damage the filter. We make sure it's not like, squeezed in, and so on. And also here, a little tool enables us to open the door without having it falling down. So there is also a stopper. Looking at the pre-filter change in a video, you can see how easy that is. Just open the door, can be slided in. And typically here in this case, we are using a G4 filter, just to protect the HEPA filter from the fluff, some larger particles from the room. So very easy and convenient process. In regards to the wall installation, we also had to think a little bit deeper because there are some tricky things. If you are installing it in the wall, we have still these, what are we calling them, the mounting blocks, and you might not be able to access them all. So maybe on the one side, it's okay, but on the other side, there might be things in the way, so you can't access them. So for this, we came up with a different solution, which I will also show you here in these animations. So it's a quick lock kit that enables you to install the housing with less than 5 minutes. So we are using these sheet metal ankles from both sides, and as you can see, the operator can reach the other side easily without even going there. And then to lock it in, we use these bar with 2 threads, compressing them, and the housing is fixed. I think you got the point. So this is, by the way, also possible for the ceiling installation. So how do we do the filter test with such kind of housing when it is for the exhaust air? We see the filter from the room side, but we know the air goes in and doesn't come out. So we can't go ahead with a manual particle counter to test the filter surface. We have to test behind the filter. And that is another challenge. How is this done normally? In standard applications, we would use a static probe. And I would like to go a little bit more into the detail of this principle here. I know we have seen it before, but it requires some more details to understand the idea of this housing. So we do have normally the furthest upstream, the port for the aerosol injection. And then we need, just in front of the filter, also a port to test the 100% concentration. So the concentration just in front of the filter, in order to know, is it enough aerosol or not? And then, of course, downstream, there will be another sampling port to see, are particles coming through or not? However, in this case, if we have a too little aerosol amount, it's likely that it doesn't really achieve or reach the upstream port, and therefore we are not sure if we have enough aerosol or not. So another root cause for that might be that the injection port is also too close to the filter. That means the diffusion is not good enough, it's not well enough distributed, and we will not know what we measure there. So also, if we have a leak in the filter, and by accident, by luck, the aerosol comes to the leak, we still don't measure anything downstream with this static probe. What is the result of measuring nothing above the filter? Normally, the operator in the room is calling the guy in the technical area, I don't have enough aerosol. I need more, please pump it up. And that means we will have just more aerosol. We might have a good enough distribution, but then with a static probe, we still don't measure anything behind the filter and don't know if it's a leak or not. The answer to this might be more sophisticated downstream probes with this kind of shape, sometimes like a butterfly, or others, sometimes it's round, and you increase a little bit your chances to find the leak, but it's not guaranteed yet. The only way to guarantee that you really find the leak is kind of scanning the whole filter surface. And that we do like that. So in Camfil, we are using, for this case, a multi-point aerosol injection, which really allows a nice distribution above the filter. So a good diffusion, even by using low aerosol amounts. That means also we have a lower filter oil loading, longer filter life, energy saving. And this means we have a very reliable 100% measurement. We know exactly how much comes to the filter. And then sampling the leak or looking for a leak downstream is possible by scanning the whole surface of the filter. So we sample the full airstream section with our probe, and that will find the leak. We call this mobile integrity probe, and how this looks, we will see in a little bit. So clean seal exhaust can also be used with a static probe, but that means, yeah, you need at least 1 meter behind the filter to have the static probe, and that is clearly outside our housing. It will be in the duct. With the clean seal exhaust integrity, we have everything inside the housing. We can be very close to the filter when we scan the whole filter surface. This is what it looks like. The people in the room have seen it outside. The people online will also have now some short animations and videos. But basically, the housing itself looks like a clean seal. It has a standard open plenum filter chassis. In addition, we have a modular body where the mobile integrity probe is installed. And also we have this whole thing 100% pressure tested, because there are gaskets in between. It can't be fully welded anymore, but we use the gaskets we also use for safety housings, so no risk from that side. In addition, we have a control box, which is the point of access from the room side. This is the point where we can now add the manometer if we want, but we also have one here installed. And this is the point where we operate the probe. So this is the so-called scan drive, and also the port, of course, for the particle counter / photometer, whatever is used here. And then we have a flexible shaft to drive the MIP. In order to do this, we need another tool, because it's a Camfil MIP driver, either powered from a cable or with a battery pack, and that is working like this. So we have a video for the whole process. I think there is some sound. Let's see if that works.
In some controlled environments, potentially harmful compounds are removed to protect people, processes, and your product. The Clean Seal exhaust integrity has been designed to help safely deal with these compounds. The unique grid design allows an easy integration of pre-filters to remove larger particles and protect the Hepa filter. Another patented Clean Seal family design feature are the adaptable, tool-free, quick filter clamps, which allow the integration of different Hepa filter depths for enhanced energy performance. The manual integrity probe allows for an easy, room-sided, non-intrusive filter validation to ensure optimized system performance. An optional testing shroud can support with an ISO 14644-3 compliant aerosol challenge. The control box with filter DP manometer provides convenient access for the integrity probe drive, as well as particle counter or photometer connection, ensuring that all contaminants are safely captured to protect your people, processes, and the environment.
I like this a lot. Yeah, really good. So does it work? You have to know that as well. And that's what we tested, of course, thoroughly. Testing it and comparing it with the ISO compliant static probe 1 meter downstream the filter. For that test, we prepared a couple of filters with a couple of different leaks. So we had leaks in the center with 0.5 millimeter and 0.8 millimeter diameter. We prepared some leaks in the corner of the filter, same size. And then we prepared also a leak at the gasket using a capillary here with 1.6 millimeters. So this is quite a large leak actually. Then we added the aerosol also with the qualified shroud there on top of the filter to make sure we distribute the aerosol nicely in front of the filter. And then we made the test. And the result were that with the ISO 14644 compliant static probe, we did not find the corner leaks, no matter which size. We didn't find any of the center leaks, no matter which size. And we were lucky we found the gasket leak because it's really, really big. With the mobile integrity probe, you can see the results. It did find the gasket leak. It always found the center leak, both sides. And it even found mostly both of the corner leaks. We have it red here for the really, really small one, the 0.5 one, because it didn't find it in every single case, but mostly it also did. So very much superior to the actual ISO principle. Summing it up, the design of this housing is, as always, modular. So we have the opportunity to configure it for all different needs. We have 6x6 sizes, 3x6 sizes, 3x3, and more. We can use it for the wall installation as well as for the ceiling installation. As I said before, we have different doors with or without pre-filter. And here for the connection to the duct, it can be rectangular or circular. About the testing shroud, the part which makes sure we can inject the aerosol with a nice distribution. There are also the qualification documents which proves that it is distributing the aerosol much better than it actually required by the norm in every way. Which again allows us to use minimum amounts of aerosol. We don't need to really pollute our system here. And it's a direct injection to the filter, only the filter which is currently tested. And that means also your measurement is going to be reproducible. Yeah, exactly. And finally, also no false fails. So you don't remove a filter because it has a higher measurement at one point, just because on the other side, the aerosol amount was super high. Last topic, the filter test protocols. It has been addressed briefly before, but I have some news here at this point. So again, in the pharmaceutical industry, you all know there are many standards, many guidelines, many bodies which give us the rules how to operate. And for us as a filter manufacturer, there is the EN 1822 and the ISO 29463 to tell us how to classify and how to test the filters in our factory. In principle, it's always the same. So we pre-filter the air. We challenge it with aerosol. That means we add the test aerosol. It goes through the filter. Several particle counters in the MPPS. And then we see if there are any leaks, if the global efficiency is okay, and if the filter is leak-free, and also if the pressure drop is what we promise. These test results are then documented in the scan test protocol, which is very important. But in regards to the filter classes, just a reminder, most of you will know the H13, H14, U15 efficiencies. Nowadays, they can also be called ISO 35H, 45H, 55Q, and so on. And there are filter classes in between to cover also the American normatives. This is what the scan test protocol looks like in Camfil. And it's important to know that a scan test protocol is only a scan test protocol when it contains all the information which I show you here. So it has to be clear which machine was used, which norm was applied, and which particles were used to challenge the filters. We need a date, the time, of course. And then we can see here on all individual points, how many particles do we count downstream. We need the description of the filter. It has to have a serial number. And of course, the targets for the test. And on the other side, the respective results of the test. Is it really H14 if we claim it is H14? And then there are more parameters to document. So what is the particle size? How many particles did we have in front of the filters? Temperature, humidity, all these kind of things must be on a scan test protocol. The norm says that. Don't accept a paper which just says, okay. That's there often enough. So, and then there are more parameters to see. Again, don't accept something which just says, okay, it has to be a scan test protocol. And this comes with every single Camfil filter. Every megalam has a scan test protocol attached to it, and also a label. This is a label which shows you the nominal data. So it's a main label which is fixed to the filter. Then we have a customer label, one that is removable, and a third part which we actually put to the box. So once you unpack a filter, you will find those two. That means there is one smaller part available for whatever purpose we have, putting it at the housing and so on. Now, what's my point about this label? We have changed it a bit according to the need of a certain problem. So scan test protocol comes with a filter, but during the installation, it's not always clear where it goes. So sometimes the people actually forget it at the filter, and sometimes it gets lost in the documentation process. Not a problem though, because we have them all documented in our database. That means every customer who lost the scan test protocol can just go ahead, call Camfil. Sorry, I lost my scan test protocol. Can I please have a new one? And then normally the friendly Camfil person says, yes, dear customer, we can send it to you. Just give me the serial number. Okay. Serial number should be at the filter label, which I don't see when the filter is installed. So now we have to remove the filter from the installation. Not a good idea. How do we solve that? We changed the label. We added small parts which are actually showing the serial number in numbers and as a QR code. And one of them we put at the edge of the filter that is visible from the room side. Now I have the serial number, I can call Camfil and I can get the scan test protocol, or by using the app. So this is my phone, please ignore my voicemails down there. It's showing you how the app operates. I click on identifying filter. Now I can either type in the serial number which I just found at the filter, or make it even easier using the camera. Then I just have to go to my filter, find this little sticker I just described before, and scan the QR code. It worked. If I'm online, I will straight away download the scan test protocol. I can check it. It will always say pass if you retrieve the filter from Camfil. We don't send any others out. And then I can add this one to my results. And in these results, I can sort them by date. I can delete them. I can archive them. And if I want, I can share them. And here for this, I select the filters of a certain room. And then I choose the sharing functions my phone provides. In this case, I'm using here Microsoft Teams and share it with the, let's say, validation team group. Well, okay, I did not in this case, the different group, but you know what I mean. So that's the idea behind the new app, My Camfil Connect. Solving lots of problems, I hope. And now I would like those of you who don't have this app yet to pick up your phones, scan the QR code, and it will directly bring you to the screen. And I think we can leave it there for a few minutes when we change the person on the stage. And having said that, it's only thank you very much for your attention and have a good day.
Muchas gracias, Benjamin. Buenas novedades.
Thank you, Benjamin. And that was good news. Right, we're going to finish this part of presentations. Oh, sorry, I didn't ask. Are there any questions about what we've seen so far with Benjamin? Any questions? Are there any questions? This is your chance. No, you're okay.
Como comentaba, seguiremos con la última presentación
As I
relativa.
was saying, we're going to our next presentation on indoors air quality. As you know, there are UNE norms on indoor air quality, and sometimes we don't know whether we comply or not. We're talking about non-classified areas such as office areas. Camfil has incorporated to its service portfolio the performance of indoor air quality audits. In our service team, we have 11 TSKI, which are hired technicians on indoor air quality, who are qualified to carry out these audits. Ruben Bahamonde, who's head of service for Camfil Spain, and V. Hoppengraft, head of Radical Health, who's Camfil's partner in this field. They're going to talk to us on the subject.
Buenos días a todos. ¿Se me oye?
Good morning. Hope you can hear me. Yeah. Yes, hope you can hear me. Excellent. Thank you. So we're going to talk about indoor air quality. Indoor air quality is a concept we use, IAQ, to assess precisely that, indoor air quality. It's pretty self-explanatory. Why do we need to do that? Well, this is to do with comfort and health. We're talking about people, not processes. How important is this? As our vice president would say, let me give you 2 facts and figures. 1, we spend up to 90% of our time indoors, and the indoor air can be up to 50 times more polluted than outdoor air. This can have a huge impact on our health. When we talk about indoor air quality, we need to consider it from different points of view at different stages. I see 3 pillars. First, I think of design. When we're thinking of a facility, we need to consider indoor air quality. Then when we implement that design, or we are building that design, we need to consider indoor air quality. And when we do maintenance, we need to think of indoor air quality. We also need to think of indoor air quality when we do audits. We need to apply certain processes and procedures which need to be documented and need to be part of our quality management system, for example, ISO 9001. So it's very important for us manufacturers to think of IAQ, because when it comes to IAQ solutions, our products need to comply with certain standards and need to have certain certificates. All of this also has a certain energy efficiency rule. So, I mean, we could have really good indoor air quality, but at a very high energy cost. No, there are standards for all of this. When we're talking about design, execution, or maintenance in any of the 3 pillars, there are certain elements to take into account. When it comes to designing a building, it's important to know where the building is going to be, how it's going to be used, what kind of occupation it's going to have, because depending on that, we'll have to comply with certain IAQ requirements or external air quality requirements. Now, when we implement the building, when we actually build that, we'll have to respect design conditions, unless it is to improve it, to adapt to standards. I mean, it is very important to set up certified equipment. Imagine that, you know, you are going to, I don't know, set up something in a pharmaceutical lab. You're not going to go to the zoo and say, hey, could I have that 2x3? Go on, make it cheaper. No, hang on. You need certified equipment because you need guarantees. We're talking about health. You need to be very, very careful, very cautious. And the implementation, the setting up of the whole system is crucial. And for indoor air quality, it is essential because we need to make sure that the results are going to be good to start with, and then throughout, we will have yearly audits. And then when it comes to maintenance, maintenance has to be done by qualified personnel. And it's also very important that IAQ audits be done periodically, as the standard said. We need to make sure that the air vents are clean and that we have certified filters. We cannot buy them in the Zouk. We're talking about health here. We need the right products. And it is very important for me, this is the crucial bit, that all of this be documented and be part of quality management system. Why? Because both the facilities and the standards are alive, they change with time. RITE in 1998, they already talked about indoor air quality. So we may have a facility from 98 and it was compliant back then. But then there have been refurbishments in the facility and there have been 3 changes in the standard. So what we did back in 1998 was compliant, but with the different changes, we need to adapt to the regulations. So if we don't have a continuous improvement quality management system, we're going to be stuck in what we were doing 24 years ago. We need to have the flexibility to adapt the way we assess IAQ as the standards evolve. Look at this. 50% of large companies do IAQ in Spain, but only 6% have their own quality management system, which respects UNIS 17-13330 standard. Let me read it the other way around. 50% of the companies don't do IAQ audits, and 94% do not have a quality management system that complies with UNI 17-1330. I mean, a system which complies can provide IAQ, which is 24% to 67% better than buildings which do not comply. Now, this is here throughout the building life. This is written, it has to be complied with, right? It is present from the beginning of the design until we demolish the building. So design, building, implementation, and maintenance. And then we have UNIS 16798, which is about filter energy efficiency. And then we have IAQ standards, which are come into effect in the second half of the match when we start using the building. And that standard is going to be applicable throughout every year. That's why it's so important when we start using the building. That is going to give us the baseline for all the other measurements. These are the standards that apply for IAQ. And the standards are kind of interrelated. They're a whole loop and they take us from one to another. So we have RITE, from which we have UNI 17-1330. From this, we have UNI 10-0012, 1377-9, UNI 14644, because non-controlled atmospheres also need to be classified with an ISO. I mean, it's lower, but it also has its own ISO. So we have also the ISO for filters, to talk about classified filters, and EN 1822 for absolute filters. This is done by the Standard Technical Committee CTN 171 in Spain, which is based on royal decrees, ASHRAE, NTPs, UNI-CTE, HS2, HS3. So what happens if we don't comply with these standards, if we don't pay attention to audits, and we just let the building run its course? We can end up suffering the sick building syndrome. The WHO estimates that 30% of modern buildings suffer this syndrome, and it is a series of diseases and concerns which a building causes in its occupants because of the poor state of the building. When I say the poor state, I don't mean the building is crumbling down. No, it just cannot provide the right hygiene and health and safety conditions for its occupants. And what does this mean? This means we end up with this series of symptoms. We can have headaches, irritations, colds, feeling of dryness, nausea, lose our voices, all sorts of things. All of this can come from a poor quality, for poor indoor air quality. And also, if people are ill, they don't go to work. And this could end up costing the company 5%. Imagine a company whose HR costs is 200 million euros. So that's 250,000. Every 4 years, it's 1 million euro just because of poor IAQ. That amount of money could be invested in improving the facilities, having better solutions for clean air to improve IAQ, replacing old systems for new ones. There are also studies that prove that poor IAQ can limit cognitive performance in over 20%. So the other way around, a building with good IAQ means that the people inside have a 26% better cognitive performance. They sleep 6% better, and they suffer 30% less sick building syndrome. Now, this is a study carried out by Harvard University and Carrier. This is a link to it. It's in English, it's easy to read, and it has very interesting information. I strongly recommend you read it. This is what Uni 171330 says. This is the minimum criteria for acceptance for IAQ audit. I'm not going to go to acceptance criteria or who is going to do it. My colleague will tell you all about it. Just one thing. What this says is we need to do a hygienic assessment of climate system, and it talks about ducts, and it talks about 112. Do the ducts need to be cleaned every year? Not necessarily, but they need to be assessed, looked at, do a microbiological control, and depending on the results, you may need to clean them. If a duct is dirty, filtration at the top is not enough. So all of this needs to be assessed. Then you need to check relative humidity and temperature. That's what the RITE says. This is going to be updated now. This is the old chart. The technical committee needs to adapt this to the new standards. It says that we need to measure dioxide, the CO2 and CO1, and it mentions the royal decrees. It talks about bacteria and suspended fungi. This has certain tolerance margins. It needs to be done. And then we need to measure suspension particles, and we need to count particles according to 14644 standard, which is ISO 9. This has to be done every year. And it takes us to this norm that we all know. So when we classify a room for an ISO standard, this is the rule we're going to use. We have to determine how many sampling points we have and the number of particles we can have for 0.5 and 5 micron, and how we achieve a low particle concentration. Well, with the right kind of filters, with clean air. So we need to go to this standard that tells us the kind of filters we need to use and energy efficiency. And it tells us that filters need to comply with UN and ISO 16890. They have to be certified, tested, verified. And if the inside air quality is sub 1 or 2, then we need to go to EPM 1, 70, 75. Filtration efficacy and efficiency need to be equivalent to Eurovent 423. Eurovent is an external standard body. It is like a referee. Now, this means that any filter non-certified by Eurovent should not be in your facilities. And it also says that if our building is in a very polluted area with lots of gases, we're going to need molecular filtration. We need to get rid of those gases. And they suggest the following. This comes from the pandemic. We have just been through. The return air circuits, it says that non-controlled air areas need to have at least EPM1 filter or even absolute filters. So if we need all these filters, the rule also says that we need to be careful with when we're going to change those filters. This is UNN ISO 16890. Efficacy, efficiency makes sense because all standards are related. This is energy efficiency. This rule, this standard tells us when the filter needs to be replaced. Before, these were the rules, and we could go through 300 pascals. This has changed. We can no longer do the same pressure, changes pressures. We need to take each of the machines, put the filters in each of the stages, measure the initial pressure, and follow this. So the procedure has changed, and we need to adapt. We can then now add 100 pascals or multiply by 3, the lower value. So as you can see, all the standards are interrelated. We loop the loop, and we just come to say that indoor air quality is very important. We spend a lot of time indoors. There are standards and regulations that mean we have to do periodic controls, and they affect all the stages: design, implementation, and maintenance. You need to have a good quality management system. The systems we use need to be certified. The filters need to be certified. Everything needs to be documented, and this is all for health. We've just been through a pandemic. Many people have lost loved ones. We need to be careful. And also, it's compulsory. We need to comply with this. Thank you all.
A ver si ya funciona esto. Hola, hola. ¿Todavía no? Sí.
Hello, hello. Is it working? Yeah, it is working. Okay. Well, good afternoon, everyone.
Good afternoon to everybody who is watching from wherever in Europe. Mi nombre es Uwe Hoppenrath.
My name is Uwe Hoppenrath. I'm the co-founder of the Radical Health Company, Radical Healthcare Company that collaborates with Camfil in certain segments, such as the distribution of camp cleaners that we have with us here today. And we accompany these physical products with a set of customer tailor-made services for our clients. One of these services is a topic about what I am going to talk about in the coming in the next few minutes, which is the quality of indoors air. Legal framework has been perfectly explained by Ruben. Well, we do these studies based on 171 UN 171/330 that we have heard about. The final goal of preparing these studies and tests evidently is to achieve a good indoors air quality in order to guarantee the welfare, the comfort of users in a building. So we are regularly informed by the WHO about the environment in different parts of the world. And in the last report from 2019, well, we heard that practically all the population in this planet is living in areas where the directives of the WHO are not respected, and 92% of world population live or breathe contaminated or polluted air. Due to all this, 7 million people die every year. Premature death, I'm speaking about premature death. It's an incredible figure. Only in Europe, we're speaking about 500,000, and in Spain, 30,000 premature deaths every year. And unfortunately, these figures continue growing, and we expect to reach 10 million in the year 2050. Therefore, we have to do something about it. The worst possible news is that we found a vaccination against coronavirus, but against this problem, we have no vaccination whatsoever. So oftentimes, well, better said, humans have, in one way or another, achieved something which is magic. Unfortunately, it was black magic or brown magic, because we've been able to turn something that was invisible in the air into something visible. We were able to contaminate, to pollute the air in such a way that we can see it with our bare eyes at a certain distance. These are images, real images of both Madrid and Barcelona. And what we normally see evidently doesn't seem to have a very nice or healthy look. So when we think about air, we have to understand different types of air. To start with, outdoors air is the base of what we breathe in the indoors areas. But also, if we go from the original recipe that nature offered us, which was 78% nitrogen and 21% oxygen and 1% other gases, and to this original recipe, we humans, through our evolution, industrial revolution, and many different inventions that we devised, we've added other ingredients to the cocktail, to the original cocktail. Hydrocarbons, organic compounds, volatile and semi-volatile compounds, an endless list of chemicals in order to turn the invisible air into something visible. Having said this, when we perform a study about which has to do with quality air, the quality of air, we act according to the BBCA philosophy: plan to check, verify, and act. When we translated it to Spanish, applied to the UNE 171-330, we see 5 steps that we follow when we visit a company in order to make such type of studies. We have some steps that chronologically we take, and the first step of them all is inventories. Well, first of all, before we visit a company, to have as much information as possible about the building or the offices, and such as, for example, we ask for projects, maintenance plans, user complaints, doctors' reports about the company if they had their own physician. And once we are in the company, we'll interview people to see if they are feeling okay or they have a problem or something. Very important also to consider for this type of studies that we need to know where the building is located. It is different to have a company in an industrial area where next to it we have other companies that issue fumes and smog, as we are, versus being here where we are surrounded by a green area. It's also the activity of the company has an influence in the company, the density of staff, and above all, the building materials that have been used when building the building, due to the materials, the paints, the furniture. We know that this generates contaminating particles that pollute the inside air, which constitutes a group of endogenous contaminants of buildings that are added to the already polluted air that comes from the outside. And oftentimes we have chemical reactions between these different agents, and very often these reactions are unknown to many of us. So the cleaner the air, the better. Obviously, we always study on the maps the air, water, and hygiene facilities, the high-level technicians of air evaluation. We try to study the potential that different parameters may have on the quality of air inside the building that we are inspecting. At this stage, we don't measure anything. We don't take any samples whatsoever. Rather, we visually inspect the building in order to find out whether we have important aspects or not, and what is the likelihood to have these aspects, or to turn these aspects into a light, medium, or severe effects. And then the technician will determine what to measure, where to measure, and how many points to measure. And now we are at the practical appraisal stage, where we quantify the different parameters that will give us certain levels. We measure different parameters, some of them mandatory, some other are complementary, as we will see in the next slides, through direct measurements with our pieces of equipment. We take samples in the building, different offices, different areas, and we take samples of possible biological contamination inside the ducts, both on the surface of these areas as well as in the air that crosses the ducts. From there on, we evaluate the real risk for users of the building, and then we set two different well-defined criteria determined in 171 330 standard. On the one hand, we have comfort values, and on the other, we have limit values. In no cases can be exceeded. If we exceed one of them, the building automatically should receive a non-conformity report. Next to the comfort values, the regulation is more permissive, and it defines that we have to fulfill at least with or have to comply with at least 70% of all parameters that we have to measure. And well, we'll have to find the cause why the remaining 25% is not compliant with the comfort criteria or values. And for them, we propose correcting actions. We have to correct any problem that may worsen the air quality inside the building. Now, once we know all this, and knowing that the quality of indoors air depends on different variables, well, we don't really have to do it once a year at least. Well, we have the snapshot of a day at a certain time, but doing it just once a year, no use. Well, it's a variable parameter. In a few minutes, we may have a completely different situation. Therefore, so we should consider how to prepare a video, not a snapshot, a snap video that integrates this type of philosophy of air quality in certain plants inside of a system of management. And Ruben also mentioned ISO 9001, the preparing different plans, maintenance, revision, cleaning, etc. In order to optimally integrate it 100% into the management system, such as 9001. So the standard defines mandatory parameters that need to be measured and controlled at all times. These are the ones that we have in the list. And the first one is the hygienic evaluation of evaluation systems. Ruben talked about it before: temperature, relative humidity. I'm not going to read it all. It's a quick list. Other than these mandatory parameters, we have to decide through that visit on the building, and we have to see where the areas that the technician determined that there are problems, and we have other complementary parameters, such as, for example, lots of noise. This has a clear influence in the level of comfort and well-being of users. It lowers performance, it reduces the cognitive capacity. And then we have other parameters, which may be an inadequate lighting. This may generate some electric or electromagnetic fields. There may be static electricity. All this has negative repercussions on the comfort of people, even in the case of healthcare. Semicircular lipotrophy was found in different buildings, particularly in Barcelona. Then we have formaldehyde, ozone, radon, air copes, which entail a danger, and we have to exclude this type of contamination in the buildings as a source of problems that need to be solved on a short-term basis. We also have to understand that fibers such as asbestos shouldn't be part of the air that is breathed inside the building, wherever it may be. However, this graph, as we could see before, mentioned that we have to fulfill 75% of all these parameters, comfort parameters, while finding possible causes for the rest of the parameters that do not comply with this column here of the graph. Now, as a goal, as an example, I will deal with two of the mandatory parameters that we need to control. The first one being the ventilation system. We may evidently find the right position and also ducts that are similar to what you can see on the left side of the picture, where evidently we have a duct that is quite dirty and that may cause a long list of possible negative consequences. In the presentation, we could see this in Ruben's presentation. This could cause diseases that may generate a fungi and spores proliferation. This may increase problems to people who are asthmatic or allergic, and evidently for these people may mean a real problem for their respiratory system. A ventilation system isn't just a single network, but there are the several networks that need to be controlled. The recirculation or the propulsion networks need to be revisited, and not to forget the other components in this system, such as the air treatment units, condensation trays, grids. Well, all this is controlled and needs to be controlled mandatorily during an inspection according to 71330 standard UNE. Not to forget any of this, the technician will prepare different checklists and also a checklist for the ventilation system may include or may look like this, where we have the different components to be delivered and to be controlled. Second parameter, on the other hand, that I will deal with in greater depth to see what we do, has to do with the particle size, the particle type. Well, are interested, that's defined by the standard. Well, three different sizes. The first one, particles in suspension, PM2, 2.5. These particles, as defined by the standard, need to be weighted, and they have a value, a comfort value. Well, this was not part of my presentation. They have a comfort value that needs to be found below 20 micron per cubic meter. Camfil has a specific system to particularly measure these values, which is called air image. This is a small intelligent sensor that weighs on a continuous fashion in real time the load of particles And it also is capable of connecting and managing up to 7 camp cleaner devices, more contamination, higher level, automatically controlled environment. Well, air image, remember. And then we are interested in 2 other particles, 0.5 micron and 5 micron. And these have to be counted. It's not enough to weigh them, but also counted with particle counter. If we have a high level of particles of any of the 3 sizes, logically, the cause normally is the same: dirty meshes, filtering, inadequate filtering, ventilation equipment, and improperly maintained circuits. And evidently, I said that before, in the inside of the building, we may have the cause of it all. So we have building materials, things that will once again cause different problems that may be affecting comfort as well as health. Here we see a direct measurement system, particle counter, that measures all type of particle sizes. And as we could hear before in different presentations, we actually know and we remember that 99% of all particles are very, very small, 99%. Smaller than a micron, below a micron size, and the rest are bigger particles that involve a greater weight, higher weight. Therefore, these smaller particles should be interesting for us because, as we could hear before, they penetrate more deeply into our respiratory system. That's to say, the smaller, the deeper they get into our lungs and bodies. In the case of the smallest particles, the ultrafine, ultra-thin particles or nanoparticles, they may cross alveoli while reaching our blood flow, therefore being distributed all over our bodies while accumulating in certain organs, and at certain moments generate diseases of certain magnitude. Therefore, this slide is solving an enigma of humankind, because from now on we'll know that the size does matter, but in a reverse way, because the smaller, the worse. Well, the good news, on the other hand, is that the environment, the indoors environment, is relatively simple to control and to create a practically perfect system, better than in the Alps, 2,000 meters height, with the products offered by this company. We've seen a very important part of our portfolio of products, and we have to understand, as we could hear before, that beyond the physical product, Camfil offers a big portfolio of services in order to accompany their products while offering a real solution to problems. Now we have our second part. And in the second part, I would like to offer results of certain scientific research projects from the most prestigious universities in the world. Oftentimes they are American, where we could hear about the relation between the quality of air and the strategic decision-making, or the cognitive capacity is that, well, what is the influence of a good or a bad air on these parameters. Case number one, MIT and Maastricht University, where they took the example of chess players in official tournaments, and they research the error rate if the error gets worse. That was the purpose of this research, this investigation. Chess is a perfect activity in order to study this type of influence because it is a complex activity where different strategic decisions are made with time pressure. This happens very often in companies, and this very well simulates something that should be of our interest. Therefore, the result of the study was that increasing the level of PM2.5 and CO2, well, we got the following result: an increase of 10 milligrams, only 10 milligrams per cubic meters of PM2.5, which increased the likelihood of wrong movements of amongst professional players in a 26.3% of cases. We're not speaking about 5 or 7 or 20. Well, it's 26.3% more errors with bad air, with a bad air quality. With respect to the CO2 load, we can see on the left side of the screen with CO2 levels very similar to what we find in the outside air, where we have approximately 400 ppms. Well, decisions were right in a vast majority of cases. We can appreciate, on the other hand, that more or less at a level of 900,000 ppm, well, there we have a turning point. From there on, decisions became in a free fall into the worst possible solutions, not as the decisions made by professional players. And with a level of 1,500 ppms, maybe I would be able to win over one of them. So these are or were the results of the first scientific study that I wanted to present to you. We have more. Oftentimes, responsible of maintenance, certain companies have to face dilemmas. They are maybe interested in having or enjoying better air quality because these people receive complaints from the people working in the building, but that he or she is incentivized by saying you have to reduce costs. Maintenance costs too much money. How does he or she make it? Well, he will reduce renewals, he will reduce the ventilation from the outside, and he or she will reduce from one filtering category to a smaller category. Costs less, and therefore I am fulfilling my duties and I get a bonus. Well, it should be quite the other way around. Let's just say we should incentivize these people while thinking about the performance of the full building and offering a healthier environment. Why? Well, because with air in optimum conditions, productivity is increased amongst the workers, and now we will see what it all means in terms of quality increase. They really reduce their level of mistakes, and will be avoiding expenses, as mentioned by Ruben, due to absenteeism that will cause tremendous damage to companies and to the social security at a macro level. Such absenteeism in Spain, and you'll be surprised by it, means a tremendous damage to economy. of Spain. These are real figures of last year. From last year, we lost in Spain, we lost due to absenteeism 39 billion euro. 39 billion euro. This is a tremendous figure, too much, too high. This can turn into 1,800,000 hours lost time, wasted time. Not only the bad quality of air has an influence on it all, but also the reason, the main cause of absenteeism is still the flu. In this last trimester we are now about to enter, at least in pre-pandemic time, the flu was factor number one for absenteeism, and flu as coronavirus is conveyed through the aerosols, through the air, airborne bacteria or viruses. Case number 2, Harvard. Harvard, in that respect, is very high activity. They have a public healthcare institute, the THN Hans School, that does a great deal of research in that respect. And they have studied, in this case, what happens if we double ventilation levels. They have studied the cognitive capacities of users of a building in particular, or actually they were different buildings, and the result was amazing, because with by doubling the ventilation rate, they estimated that this has a relatively low cost and controlled cost. This was estimated depending on the climate area. In the US, the cost was from $10 to $40. Maximum was $40 cost to double ventilation. But the result that they obtained with this simple improvement had a value of $6.5 billion per person, and $40 performance, $6,500. I'm sorry, better contribution to the company. This means a factor of 162. Very few investments can yield a return on investment of this magnitude. And this was a very important concept. We have to understand what kind of investments in that respect we can do. As Ruben said, well, we don't play with our health. This is not expenses, these are investments. Let me invite you to a small figure game. Ruben did something similar here. We'll see it now in further detail.
We're going to design a company. We have a building with 5,000 square meters, 300 employees, and the average wages is 30,000 euro. Now, we are going to use a couple of figures that come from the International Institute for Thermal and Environmental Comfort from Denmark. After some research, they said that absenteeism goes up by 5% and productivity goes down by 5% in poor indoor air quality. This means the following. Labor cost is 9 million euro. Just in absenteeism, the company will be losing 450,000 euro. And in productivity, they'll be losing the same, 450,000 euro. So if we apply the double of the cost of doubling air quality or ventilation, according to Harvard, which was, we said, 50 euro per employee and year, that gives us a cost of doubling the air renewal rate of 15,000 euro. So with 15,000 euro, we can reduce absenteeism. If it is just by 1%, we've been saving 90,000 euros. And the same thing for productivity. Again, we'd be saving 90,000 euro if we just improve a 1%. So again, let me make it clear. The money spent in improving indoor air quality is not an expenditure, it's an investment, and a highly profitable one at that. Another case, same university, Harvard. They studied the cognitive capacity of some people, all high-level professionals, architects, designers, software programmers, engineers. They were in an office which could be representative of many offices in the States or in Europe. And for an 8-hour day, they did their job, as you know, as they often do. And they challenged them with different levels of volatile organic compounds and CO2 levels. And they had to see how they performed cognitively in different VOCs and CO2 level situations. The result is fascinating. 61%. Well, let's say, hang on, I forgot something interesting when it came to defining the levels. The conventional level, the air was the same air as in an average company. Then we had green days where there were fewer volatile organic compounds. And then we have green plus days where there was, on top of reducing VOCs, there was more air renovation, more ventilation. So results. The average was 61% better results on green days than on traditional days, and 101% better on green plus days. And the difference between green plus and green was still 25%. So better decision, better cognitive performance on green plus than on green days, so with doubling air ventilation. So the renovation of air, and this is pretty inexpensive. It requires a very low investment, and it can bring about huge improvement in our employees' performance. Another Harvard study, pretty similar. In this case, it was carried out in different world countries: China, India, Mexico, Thailand, UK, and the US. The cohort was people from 18 to 65 years of age, same setup. They measured CO2 and PM 2.5 at different work centers. They had their own sensors. And then following a certain software, when there was a change in a parameter going through a threshold up or down, they had to do a cognitive test. The results are very much in line with the previous Harvard study. There were slower results, low and worse results, more errors, with a lower IAQ. So once again, we come to the same conclusion. Indoor air quality matters, and it matters a lot. Last case, we jump to Europe, the London School of Economics. Mr. Roth carried out a test having a look at the exams results of 2,480 students. They each had to do several exams. All in all, they analyzed 11,443 tests. They did these tests in 18 different rooms with different IAQ levels. What did they see? Their conclusion, and apologies, in this case, they measured at PM10. They measured the PM10, not PM 2.5, which was the previous case with Harvard. we see that with each 0.3%, no, hang on, results went down by 0.3% with each additional unit of PM10. So if a student was in an average room with average contamination, his results or her results compared to his or her results in a cleaner room, their results could go up by 9% in the cleaner room. The cleaner room had a load of 4 micrograms per cubic meters. There were also slightly less clean rooms. There were rooms with over 50 micrograms of per cubic meters. Their results was 13.5% lower. And in the worst room, the level was 75 micrograms per cubic meters. The results in those tests was 21% lower than in a clean room. So air quality matters, and air quality affects us quickly. I mean, a student could go into that room with a fully oxygenated brain. They sit down, but they are breathing constantly, so their CO2 level suffers quickly. So that was my last case, my last scientific study that corroborates our results, our figures. I mean, it is not Camfil saying this. It is highly prestigious universities saying this. What does this all mean? It means, first of all, that we need to think of people first, and not just the employees who work in a controlled atmosphere area where immediately their atmosphere is going to be great. No, we have to think of the office employees as well. That is our first conclusion. We need to understand what is the result of those particles or pollutants in the air, which bring about a high level of CO2, how they reflect in our cognitive performance, in the way we think. So, in summary, there is an undeniable correlation between indoor air quality and our cognitive performance. And this affects us in what we do, how we do it, and what we achieve for the company. I've also said repeatedly that the money spent in this is not an expenditure. It is an investment with an unbeatable and immediate return on investment. My employees will perform better immediately. I don't need to wait for months or years for my investment to pay out. And we've also seen with Harvard studies that the improvement in air renewal rate is actually quite inexpensive. So with very little money, you can achieve really good gains for the entrepreneur or the company. So our starting point is that we can only manage what we know. So how do we know what we need to manage? Well, we need to do an indoor air quality study. It is not the first time I speak to you about indoor air quality studies. I'm sure it won't be the last time I speak of it. I hope next time it will be at your company. Thank you. Thank you, Ruben. Thank you, Uwe. Are there any questions on indoor air quality? Very well then, we are reaching the end of our presentation sessions. Once again, I want to thank you all for joining us on this Solutions Day. I hope it will have met your expectations. I'd like to mention that we are here, some nearly 100 professionals, but we have online around 1,000 people joining us. Thank you all. I'd also like to say that we haven't had any questions here, but on the chat for the people who are joining us online, we've received several questions. We'll be answering them through emails, okay? Because we didn't have time. Finally, we're going to finish with the rounds. We have to see 2 stands per group. We'll do that now. Then after that, we'll go to lunch. For those of us who are here face-to-face, we'll do a bit of networking there. There will be live music. We'll have something to eat, something to drink. We'll have fun. And you can also make the most of our experts who will be there and come and talk to them. And finally, there is a message from Javier Turron, head of Camfil Spain. Just to finish the presentation session, may I remind you that you need to return the headsets for simultaneous interpretations. They will not work at home. Please return them. Javier. Very well. I was saying when we started that the world has changed, and the world has indeed changed. We cannot hear the gentleman very well, I'm afraid. Oh, I wanted to dance. They're not going to let me. No, I'll speak here. Never mind. I was saying the world has changed. It is changing. It is clear, isn't it? Air quality is important. We now know that. You've seen several studies, after COVID. We know that this was the first pandemic. It won't be the last one. They'll turn up and it will be exponential growth. So you're used to working in controlled atmospheres in areas where the air is essential for productivity purposes. Okay, now I think the time has come to think of other areas, other zones, because you are of public interest, as Camfil has said, as a world leader in clean processes. We never stopped working. We were essential workers. We will continue to work in any crisis. We are essential, and so are you. So I encourage you to use our new service, which is that of auditing your facilities. Now, we talk about new products, we talk about safety processes, safety changes, safety attacks, safe tools, safe everything to make sure that we cover your safety needs. But is a product ever safe? Well, no, it's only safe if it is part of a safe solution, and solution goes all the way to maintenance. We talked about changing back-in, back-out filters. They happen every 3 years. Your personnel, are they trained? They might be, they might not be. Camfil personnel is trained. We offer this service. Well, I hope you enjoyed it. I hope everybody had fun online, and those of you here, I hope we'll do this again. I'm going to ask all the speakers to join me on stage because they all deserve a round of applause. Some of the presentations were absolute masterclass, so please come join me on stage.
Piensen seguro, piensen en verde.
May I remind you, you need to think green, think sustainable, think Camfil. Thank you.
Muchas gracias por venir.